David's
He's
disappeared. I
disappeared
think we should use
altogether.
that. It's magic.
Let me turn
He's
this
blurred
off and
again.
yeah. Well, now it won't start. Oh, there we go. Welcome back. It's a brand new season.
I really love getting this back together, and it's like how the pandemic was. There was a time we had to do it weekly. There was a time when things were slowing down. We could do it monthly, and now when COVID's endemic, we get a chance to look at other things and do it in a sustainable way.
It's a great opportunity to step away from the day-to-day machinations we go through as infectious disease doctors or educators or administrators. It allows us to get into our comfort zone where we delve into questions that we're curious about, as well as we hope that our audience is curious about.
Each time we do this, I think that there is just something really special about this collective want to seek knowledge, to discuss topics that are relevant. I mean, we're all working towards enhancing future pandemic preparedness.
I think it was very, very nice the way one of the experts really linked the immune response, both in terms of response to vaccines and response to natural infections, and then how relevant boosters are going forward. And I thought he was very realistic, painted a very realistic picture of what should be the strategies.
I really appreciate how our experts kind of put all the facts into content that is very digestible and very kind of usable for anyone in the audience. If you're just reading it as a scientific fact, you might not really understand the implication and it might not stick with you. So I think I overall just appreciate how they were very able to kind of correlate the basic sciences in some instances to, you know, really what practitioners can take away and how you better apply the knowledge even in your day-to-day understanding of the disease and day-to-day work.
The interesting thing to me was the perspective that we have indeed made great strides in international collaboration. I don't think it's perfect as yet, but there has been improvement. We learned from COVID, and hopefully we'll continue to get better. We realize that we need to work with each other to address the pandemic in a more comprehensive way. What I may not have agreed with is the impact that a large donor is going to have on global health policy or global health support, not in the short run, but in a longer term perspective. I think the largest donor being 22% or $3.3 billion contributing to WHO will have some impact.
One of my favorite parts of the show was being able to promote my book shamelessly. 500 pages, 39 chapters.
Was ChatGPT one of the authors?
The only book where you'll find everything about outbreak preparedness and response in one place. It's available free online or for purchase hard copy at a very reasonable price.
Dale, we're late for dinner. Put down the book.
Where's the book gone?
Dale?
Ah, here it is. Did I mention the book?
Yeah, I think you mentioned it.
Good evening and welcome, everyone. A warm welcome to the inaugural episode of the third season of our webinar series, where we dive into the ever-evolving world of infectious disease and related outbreaks. I'm Associate Professor David Allen, Infectious Disease Senior Consultant and a National University of Singapore Centre for Population Health Strategist, who will serve as your MC for the evening. The first 2 years of this webinar series focused on COVID, but since we last broadcast in November 2021, other pathogens worthy of our attention have reemerged. As such, this reboot of our series will have a broader mandate and expanded subject matter, as well as a new name, that being Outbreaks, Updates, and Analysis. But don't despair, there'll be a periodic check-in with COVID. In future episodes, we'll discuss avian influenza, re-emerging hemorrhagic fever, such as Lassa and Marburg, in addition to topics you bring to our attention. This is a reminder to our audience that we value your sharing what is important for you to hear, so do provide topic suggestions at the end of this and subsequent episodes. I'm joined tonight, as always, by my colleagues Louisa and Dale. Dr. Louisa Sun is Deputy Director of National University Center for Infectious Disease Emergency Response, also known as CIDER. Louisa is an infectious disease consultant physician and head of the Infection Prevention and Control and Epidemiology Unit at Alexandra Hospital. She currently sits on the steering committee of the World Health Organization's Global Outbreak Alert and Response Network and serves on multiple committees in the Singapore Ministry of Health for infection control and antimicrobial resistance issues. Professor Dale Fisher is our well-known outbreak expert with experiences including missions for Ebola in West Africa and the World Health Organization China mission at the beginning of the COVID pandemic in February 2020. Dale is also chief editor of a brand new textbook, which he'll proudly tell you more about later. Welcome, Dale and Louisa. Hope the 3-year break has been restful and you're ready to get back to work. Why do you think restarting the webinar was important, and what are your hopes for it going forward? Louisa?
Hi, a very good evening to everyone who's joined us today. And I have to say, this is really a blast of nostalgia. I'm both excited and a little bit nervous to be starting this again. And I think that for me, the main reason why we've restarted the webinar is really that the last 2 series, of which I was very fortunate to be involved in the second, was really, an educational and enriching process, not only for our audience, but also for myself. I was really happy to be able to share the latest updates, and we covered a lot of topics, most surrounding COVID at the time. And I think it was just an opportunity to understand what our audience had our audience's questions about COVID, an opportunity to answer them, and just an opportunity to share knowledge.
Thanks. Dale?
Thanks, David. I want to make it easy for people because it's so hard to keep up with all this stuff. As you know, you hear it in the media, you hear it now and then, and just Mpox, which has now been running for a couple of years, and then someone goes and tells us don't forget COVID vaccines. So I think it's time just to make it easy for people and pull it all together, and we should rotate around whatever's current, whatever's in the news, and just help people understand it, I think.
Great, thanks very much. I think it's an opportunity to try to maybe emphasize those aspects of what we're reading about that make it relevant to our day-to-day practice and thinking as healthcare workers, policymakers, and just the general public. So this is a great forum, and I'm proud to be associated with it and with y'all. So we'd like to thank our sponsor, which is CIDER, the NUS Centre for, I've gone blank there, Dale.
Infectious Disease Emergency Response.
It just doesn't fall off my tongue quite yet, so give me a break. All right. Also, some of our older sponsors, the NUS International Council and the National University Health System. The interplay between pathogens and populations demands our vigilance, requires collaboration across disciplines, and an all-of-society involvement to be adequately prepared for the next outbreaks. Outbreaks they don't respect borders, nor do they occur when it's convenient. Knowledge and capacity building needs to occur during and between pandemics to ensure our range of responses are informed, prompt, and adaptable. We've reconvened this webinar, as mentioned, with the goals to provide up-to-date data, expertise, and insights from us and from our guests on emerging infectious disease to better arm you with the information you need regarding local and global events and to appreciate the associated preparedness strategies. Tonight, Dale and Louisa will update us on what's needed to know aspects of Mpox and COVID. Respectfully, then individually engage our two renowned experts, Professor Eong and Dr. Sebastian Maurer-Stroh, to explore their perspectives on these topics. Following their conversations, we'll answer the questions you've raised when registering for the webinar, and Louisa, Dale, and I will provide additional thoughts on tonight's topics as time allows. Following which, Dale will update us regarding notable events in the Center for Infectious Disease Emergency Response. And finally, I'll close the session with the long-awaited song of the episode. Before we begin, a few quick housekeeping notes and reminders. Please use the Q&A box for any questions you have during the presentation. We'll get to as many as possible. The chat function will be open for your feedback at the webinar's close and for your contribution of suggested topics. And we will record this episode, and the link will be shared with you afterwards. Without further ado, Dale, take it away.
Okay. Let's get the show on the road.
By the way, we are an hour long, unlike our prior episodes, which are an hour and a half, so it's going to be hot and heavy.
Hot and heavy.
Yep.
Okay. Let me just start with some updates, David, just to bring people up to where we are. So Mpox, which it's now called, was first identified in 1958 in research monkeys. And the reservoir is believed to be in non-human primates and also probably rodents. The first human case was in a 9-month-old boy in the Democratic Republic of Congo. And before 2022, Clade 1, and Sebastian's going to tell us all what this means. Clade 1 was endemic in Central Africa, so around here, and Clade 2 in West Africa. So that was like the endemic state, if you like. As cases started to pick up, and in July 2022, the first public health emergency of international concern was declared, and that lasted through to May 2023. And this was because of multiple cases of 2B outside of Africa. I'll come on to this soon. The mortality is low at around 0.1%, and the disease was renamed early on in that fake because there's now a global policy that names it was, of course, monkeypox, needed to avoid offending cultural, social, national, and regional sort of effects, and not have impact on professional or ethnic groups. So, and also to minimize the impact on trade and things like that. So we don't like naming it after regions or countries or cities or animals or any sort of group. So the second fake was declared just over a year later because there was more Clade 1 in DRC and other parts of Africa, which didn't have endemic Clade 1 previously. So this, So just to give you a little bit of background, it affects mostly, severe disease will occur in vulnerable groups. Particularly, there's a link with HIV and other immunocompromised things. Children, pregnant women, skin conditions, which allows it to become bacterially infected. It's spread in many aspects by spillover events from animals and rodents, but also close contact is the human-to-human way of passing it on. The incubation is 3 to 17 days. The symptoms will be like a rash, fever, obviously these pustules, which are often on the face, but often around the genitalia, because that's where the contact has often been. You can get muscle pains, painful lymph nodes, this sort of thing. And the symptoms will last 2 to 4 weeks. So now just to take you through a little bit, if you remember that the clade was initially here in Central Africa and here in West Africa. So you can see that by, when was this? By 2022 to 2025, the spread has gone to many other African countries. Now, looking at the clades across the world globally, so clade 2, which was the first fake, which was originally in West Africa, so that was here. Clade 2 is yellow, and you can see that, you know, it's really gone to a lot of other countries. The blue one has also gone in countries around this region, and also Canada. They've seen both clades 1 and 2 with green and blue representing those clades. So there's clearly been a lot of spread up until 2025, which is now. And just to clarify the numbers, you can see these dark blue colors have got more than 10,000 cases, pale blue between 1,000 and 10,000. So you can see that, you know, a lot of these countries outside of Africa have seen cases. This, of course, is DRC, which has also seen a lot of cases. And just to further clarify the numbers, you know, US has seen 34,000 cases, Brazil 13,000. These are by WHO region. DRC 10,000 cases. So this is no trivial thing. If we look at Singapore, we've seen 67 cases, but quite a lot in China, Australia. So it's really seen a lot of spread. And just to put a temporal relationship to that, you can see really it's the first fake saw a lot of those cases across the world. And really it's settled down in all regions of the world, except this top one, which is Africa, which is still seeing high numbers of cases. But their cases, you can see that these are the clade 1b, which is the current fake at the moment, which is concerning us. And I've circled the local transmission. So it's one thing to get cases exported, but you can see Germany's had 3 household contacts, UK's had 3 household contacts. And this is when we start to get more concerned, once you get that transmission, rather than just exporting cases and then the spread stops. Interesting little cluster here, 2 people separately that went to the United Arab Emirates, and that was their only point of travel. So there's a little cluster coming out of there. But this is my attempt to help you understand why there's been 2 fakes and why there's concern. Singapore, very much 1, maybe 2 cases a week over the last couple of years. So no local transmission. So with that, I would like to stop sharing and introduce our 2 guests. So firstly, Professor Sebastian Maurer-Stroh. He's the Executive Director of ASTAR, Bioinformatics Institute, and he's led the sequence analytics portfolio since 2007 and the infectious disease program since 2010. He makes key contributions to national and global viral pathogen surveillance through the GISAID Data Science Initiative, the single most important source for outbreak data sharing and analysis in the pandemic. To put all that short, he's our expert in gene sequencing and tracking mutations as they evolve and potentially what they mean. Another close colleague is Professor Eong. He's from the program in emerging infectious diseases at Duke-NUS Medical School, where he's been conducting research on and emerging viruses, including disease mechanisms for immunity, for more than 25 years, making him one of the most authoritative in the country on vaccines, and definitely my go-to guy whenever I've got a vaccine question. So let's hear what they've got to say. Firstly, to you, Sebastian, can you just help us with the nomenclature? We hear of mutations, variants, genotypes. Now Mpox is all about clades. Why do we have all these terms?
Yeah, these are different levels of resolution. Yeah, you have to think also that the different viruses that we are used to, like corona, we knew the variants, and clades we're talking about now. These are actually quite different viruses, different in terms of they are RNA versus DNA viruses, which affects the number of mutations. But to put it simpler, let's say we have an influenza genome that's this big, we have a coronavirus genome that's this big, and the Mpox virus genome is 7 times bigger. So in the larger genome, these are the letters, you can have more mutations, more patterns. So when we compare them, they become very distinct. Maybe in a more simplified view, think of it, clades are a very, very high level. For example, you're looking at car makers as a difference. And then as you go into more detail, you have, for example, the individual models of the car. And if you go into greater detail, there are changes that then maybe just neutral mutations, which end up to be just the different letters in the license plate. But why is it important to distinguish these separate levels? Well, you want to know if these cars are able to go over mountains, if they are race cars, if also how these individual changes, the small changes, affect potentially tell you about where the virus came from. Just like a license plate can tell you from which city, in depending on which country you're in, you can tell from the license plate where that car came from. And similarly, we can look at the genome, and you have small changes or big changes, and that gives us the names of clades and also variants or genotypes later.
So clades tend to be big changes. Is that what you're saying?
Yes, yeah, about hundreds of mutations. So, and this depends on the virus, whereas variants are a handful of mutations.
I see. So there's 4 clades, if I'm not wrong, 1A, B, 2A, 2B. Is that right? And can you tell me structurally how they're different, or how close are they?
Yeah. So they do have a common ancestor, and the interesting thing is, because these changes occur often stochastically, we can use the number of changes as a clock to count backwards when they all came from one common ancestor. And in the case of these 4 clades, 1A, 1B, 2A, 2B, we calculated this must have been around 1970 when they split. And the fakes that were declared happened more recently, and it's very, very easy to map the timing for those events too.
Okay. So they all came from the one version of Mpox in around 1970.
Yes.
Okay. Maybe this is a good time to cross to Eong. And I'd like to know how the clades affect vaccine efficacy, perhaps. But maybe before that, maybe just tell us about vaccines in Mpox. What's their efficacy, safety, time to full effectiveness? Do they wane? All those COVID questions.
Yeah, thanks, Dale, and thanks for having me on this broadcast. Yeah, the Mpox vaccine is essentially the newer generation of smallpox vaccine. So they're very closely related. In some ways, Mpox didn't really exist in those days when we had smallpox, because majority were either, majority were vaccinated against smallpox, or they had acquired smallpox infection, and therefore we didn't see Mpox. Mpox only appeared after we stopped smallpox vaccination. But essentially even despite the variants, because with the vaccine is composed of a whole virus that is very weakened. So the immune system does see a variety of all the different aspects of Mpox. And so it's very difficult for the virus to fully escape immunity. And so therefore, there's no concern that these, one or more of these variants or clades could escape the immunity that can be derived from vaccination.
Okay. So they're not exactly the smallpox vaccine, but they're sort of modifications of it. Is that?
Yeah, that's right.
So just tell me, elderly people like myself that have had the smallpox vaccine, are we completely immune, at least in theory? I know, many people of this age aren't really exposed, so maybe you don't know, but should they be completely immune?
I think the likelihood is they're going to be protected against certainly the more severe forms of disease. Right now, whether the immunity is sufficient to prevent an infection entirely, that's a completely different story. I mean, prior to COVID, we used to assume that after vaccination, most of us are protected against infection, not just disease, but infection. and that we won't inadvertently, become asymptomatically infected and pass it on. But I think COVID has now taught us that the bar for preventing infection is probably very high. In the past, we may not have realized it because the lab tests for infection is not as good or not as sensitive as what we have now. And as the tests get more and more sensitive, we can pick up, minute traces of infection, and therefore now we know that actually there's quite a lot of breakthroughs. But in any case, I think the goal of vaccination is to prevent disease, not infection primarily. Preventing infection is more of a nice to have. So I think with that, as a long way of providing the context, I think because most of us who have received our smallpox vaccine, we got vaccinated when we were relatively young, and so the immune response that we would have produced from vaccination would be quite broad
Strong.
spectrum,
Yeah.
and should last us for at least for life and in protecting us against a severe form of disease.
So just tell me on experience, are there cases of people that have been vaccinated against smallpox getting Mpox, or do they get Mpox but it's just not severe?
I don't know the answer to that. I'm not sure that anyone has looked hard enough.
Yeah.
But certainly looking at the demographics, although it could be biased by the fact that, as you introduce, the transmission happens through close contacts and mostly, a lot of the sexual contacts. The the older adults who would have had been vaccinated may not engage in such activities and may not be involved with that where transmission is happening. So there could be some bias, but I think in general, you're not seeing that kind of disease in the older adults.
Thanks, Eong. So, Sebastian, let's just bring it back to the practical importance. Why do we need to know these clades? The preventative measures are the same. There's no treatments to speak of. Why is so much effort being put into this?
In other viruses, a bigger component is the vaccines. But like Eong said, we do not believe that this virus can easily escape. Even with many mutations, the vaccine efficacy continues to be. So we do not expect vaccine component to be here. However, there are PCR detection that could be differentiated. But more importantly, in the greater resolution, going from clades to lineages and these variants, there is epidemiological learnings. So you do get an idea of how the virus spreads. For example, we know that some of the lineages, although they're all, let's say, clade 2B, differ even between cities. So it goes back to the license plates that these changes in the virus can tell us where the virus has been going.
So is it just interest? Is it just scientific curiosity?
No, of course. When you understand the transmission patterns, then you can change policies and potentially intervene. I think especially when there are some unknowns. For example, the second fake was about looking, is there now more household transmission? So are there different transmission routes? And you can very closely determine how the viruses are related also then between households, within cities, or within countries.
Okay. And tell me how it works in low-income countries. I should imagine these tests aren't cheap, and all that surrounds the tests, the transportation and everything, and the storage. So how does it work? I presume it's just a sample, and then it has to be sent to laboratories internationally. Is that how does that work? How does DRC know it's clades?
Yeah, well, they do have their own research labs. There is also international labs from Oxford, from Pasteur network that are helping. The first test is PCR based. This is you remember from COVID, you had the different tests. This is not the simple one that you can do at home. So you still need to bring the sample to a lab. But also DRC does have those labs, and the neighboring countries are also helping each other. The whole genome sequencing that we're using to infer the greater detail of these variants, this is also done mostly in Africa in these countries. And I attribute this to the corona pandemic because a lot of labs have ramped up and were prepared. for the first time during Corona, they were able to sequence whole genomes, and this has become a bit of a commodity, albeit an expensive one. So your question about how can this be afforded, I think it's also a core responsibility of the international community, because for infectious disease surveillance, it is very important to not get just genomes from a rich country and a lot of it. Rather, we are very interested in getting a broad distribution from low and middle income countries. So there are elements. WHO has been asking for funds from Pandemic Fund, Global Fund. The EU has contributed. Also, Singapore Ministry of Health has donated 50,000 PCR kits to the Africa CDC, and Africa CDC contributes then distributing those tests.
Yeah, I should imagine a lot of the cases are clinical diagnoses rather than even a PCR, right?
Yeah, you start with the symptoms because you have the skin lesions, and not all of them will be positive. There is also at the same time varicella that can look sometimes similar.
Okay, so I'll flip back to Eong again. Let's talk about vaccines. We keep hearing there's not enough vaccine, but it's been 3 years since the first fake. There's been 2 fakes. What's the holdup? Is there no desire, or is it complex?
Yeah, I think it's largely a issue of supply and demand, right? I think the demand isn't as high as what was experienced when we had COVID, right? And I think it partly because the spread is more in clusters, whereas COVID, it just went person to person much faster and went globally. And so there's always an issue of who funds the development and who would buy the vaccine after that, right? So I think it's all for vaccines always an issue of how does the company who's going to make it and be responsible for its safety and all that make money out of it.
So I think there's a lot of ring vaccination going on. So once you've got a case, then you vaccinate the contacts and the contacts of contacts quickly. Is this something we should be looking to eradicate, like smallpox, or because you can sort of eradicate it with infection control, can't you? Or is that unreasonable?
Well, I think we might be able to reduce the incidence and eliminate it from most parts of the world. But I think because it comes from contacts with animals as well, it's a natural reservoir. Eradicating a virus with a natural non-human source is always going to be very difficult. You can get it from a human population, but it'll still pop back from the wild, right?
It'll be re-emerging like Ebola.
Yeah. And the second thing is actually eradication is very expensive. And I remember years ago attending a seminar by Donald Henderson, who led WHO's effort in smallpox eradication. This was years after smallpox was eradicated. And someone in the audience asked him if he would do it all over again, and his answer was no. That it was at the end of the day, it was so costly hunting down the remnants and the last few cases that he thought that the money was better spent investing in horizontal programs. In other words, in activities of public health programs that cut across and prevent several diseases and not just one. So I think that answer made a lot of sense, and I think that given the issue that we probably cannot get rid of the virus from, especially when they're circulating in wild monkeys, and that it's going to be very costly. I think controlling its spread is probably the better way to go.
Your conversation reminded me of polio, but we won't go there now. But those hunting out those last few cases, sort of thing.
Yeah.
Okay. Well, look. Thanks, gents. I hope the audience feels that they're completely up to date with Mpox now, and we might update them again at a future time. But over to you, Louisa.
All right. Thank you very much, Dale. Let me get my slides up. Okay. So while we are aware that there are more current active outbreaks happening in the world, as a legacy to our previous two webinar seasons, I think it felt a bit remiss not to include COVID-19 in this kickoff one for the third season and then give it a proper send-off. So, and in fact, I just realized while doing my slides that it was just a few days ago on January 20th that marked the 5th anniversary of when the first case of COVID-19 was reported back in 2020. And what really struck me was that 5 years in the spectrum of many timelines is not a terribly long time. And I don't equate that amount of time, of course, with the amount of devastation that COVID caused. But 5 years on, and I think the world has collectively seemed to move on to a place where we've all but forgotten about COVID-19, what it was like on 23rd of January in 2022, or even still in 2023. So while we're still talking about COVID, as a lightning recap, I just want to acknowledge the significant advancements and contributions of science that have brought us out of the pandemic today. From the tools for diagnosis, treatment, and prevention, public health measures, including public education, and also because of the eventual levels of immunity established in populations, be that through natural infections or vaccinations that achieved herd immunity. And hence, of course, the impact of the virus is very different today than it was even a couple of years ago. However, as thankful as we are that we are finally able to exit the pandemic, and when I say that, I feel that everyone in their hearts may actually have a little bit of a different time point in mind as to when you truly admitted or felt that the pandemic was really over. And I know that I personally actually took a little bit longer to internalize this after the official WHO declaration on 5th May of 2023. But despite this relief, we can say that for the most part, the pandemic is indeed over. I think we mustn't forget about the catastrophic consequences that COVID-19 had on the world. Firstly, even today, there are still infections happening every day around the world, whilst with some countries still being affected more than others. And these infections continue to result in hospitalizations and deaths, despite being remarkably lower. And there are still emerging variants with slightly different pathogen properties. And so I think we're still constantly monitoring this and worried about whether another significant mutation may cause a resurgence of a more severe disease profile. And lastly, of course, I don't think the world truly knows the true cost of the COVID-19 pandemic, right? I was looking this up and I realized that a lot of the papers and published articles and research about this stopped somewhere mid-2022 or 2023. So that was when too many complex factors came into play. And I think that there was really no way to estimate the true cost of COVID, because there are not only associated costs directly of COVID, there are associated costs from other communicable diseases that have re-emerged due to a decrease in routine childhood vaccinations. There's non-communicable disease that plays a huge part due to having disrupted essential services during the pandemic, disruptions to chronic health management services. And also not forgetting, of course, the costs of long COVID. And lastly, I just want to mention that not only from disease burden, from indirect and direct disease, we also need to take into account that COVID really had a colossal economic impact on societies from both direct and indirect costs of disease burden, as well as income loss due to unemployment, as well as absenteeism. So to conclude, yes, the pandemic is over for now, but I think that if there are practitioners in the audience and myself as an ID physician, I still get a fair number of questions about COVID, especially to this day surrounding vaccines. And while we've come a long way as well to be confident about several properties of the vaccines, including their efficacy and safety properties, the complexity of the immune landscape now, getting repeated doses of vaccines and continuous vaccine updates also brings about new questions and uncertainties. So in order to help us understand this better, I'd like to once again invite Professor Wee on screen to share his insights. Right, so Prof. Wee, one of the big questions I have up front is, have we finally found a correlate of protection or threshold of protection for COVID-19?
Yes, we have. I'm delighted to be able to say that affirmatively. Actually, that correlate of protection was discovered here in Singapore. It was the work of a very talented pediatrician at NUS. She's an assistant professor there now. So she did a PhD in my lab, and she fortuitously joined up the PhD program in 2020, right at the smack of in the middle of the lockdowns and all that. And one of the ideas that we threw around was, at some point, the vaccination is going to reach children, and why don't we enroll a cohort of children? Let's see what happens. And at that point, it was just to understand how children would react to the vaccine and what level of antibodies and T cells that you will get. But coincidentally, after the study started, the Omicron wave hit Singapore. And so then we could see how well vaccines protected, and what actually, which element of the immune system actually protected against the symptomatic infection. And the answer was T cells. That was the only thing that could predict protection. So if your T cell levels were high enough, then you essentially don't get any symptoms. Whereas if you drop below a certain level, then you start to get symptoms. Neutralizing antibodies that everyone talked about, especially in the early part of the pandemic, that didn't protect at all. And the answer there could be because at that time, the vaccine strain was the original Wuhan strain, and what hit Singapore at that point was Omicron. So there was that mismatch. But what is clear, though, is that despite when the neutralizing antibodies couldn't protect, the T cells could, right? And that was the conclusion of the paper. And what we then went on to show is that if you then have hybrid immunity from a Wuhan vaccination and then an Omicron infection, then when you do get re-exposed, the neutralizing antibody at that point was so high that it would protect against anything, right? So I think what we need perhaps could learn from COVID is that there is no one single immune response that will be so important that that's all we have to depend on. It's actually in the immune system has evolved multiple layers, so that if you miss one layer, you don't have enough of one, the next layer steps up and the next layer steps up. So I think that's the story of correlative protection against COVID.
Okay, thank you so much for that, Prof. Wee. And I think, yeah, that was really one of the big questions that we had in the start. And I'm glad that we finally found it, and in Singapore, no less.
Yes.
So as I understand then, at this point, are we still generally then concerned about, how waning immunity will also differ between natural infection and repeated vaccinations, given that, we can measure this correlate of immunity, and how does that help us to study the durability of COVID-19 vaccine responses moving on?
Yeah, what we also know from this is studies done by others is that the T cells are actually quite long lasting. In fact, a colleague of mine, his office is just several doors away from mine, Antonio Bertoletti. He, at the start of 2020, he looked at the immune response to the original SARS virus from the outbreak of 2003. And what he showed was that 17 layers later, he could still detect T cells that reacted against the original SARS virus. It just shows you that how long it can, how durable it is, despite the fact that there was no re-exposure to the original SARS virus. So I think the notion there is that, because T cells form this very foundational layer of the onion model, if you like, right? So if you peel away one, there's another layer. So if the core of it is T cells, then even if the rest are insufficient to protect, the evidence is that T cells do last forever. The only caveat to T cells is that older adults, we don't make T cells, new T cells, because the T cells are made in an organ called the thymus. And thymus is there when we're young, but then it shrinks and it disappears as we age. So much by about, starting from about 40, 50, you start to lose the thymus. Actually, it starts to shrink even before that, but you lose it around age about 50. So where you do not make new T cells, then you either rely on what you have had made in the past and see whether that can cross protect, or that now you need to rely on antibodies. And so in the older adults, they are more vulnerable to COVID, and especially severe COVID. There's still benefit to booster vaccination. But I think the need for boosters is now not as generally applied as it was for primary vaccination in the heart of the COVID outbreak.
Okay, thank you. Well, actually, thank you for answering my next question, which was I was going to ask, and I realized towards the end of your reply that you were saying that you were talking about the reason why we may have vaccine recommendations now that are really focusing on the more vulnerable populations and the elderly or the our people, our residents who are over 60 years old being one of these populations. And so I just want to move on as well. So we know a little bit about why our vaccination recommendations have come about and how we respond maybe to vaccine recommendations and even repeated infections. I recall at the start, we had talked about, or there was an intranasal vaccine that was also developed. And that was because there was very strong mucosal immunity that we thought could be triggered, and therefore that was the first step to even stopping the virus from getting into our lungs. And I wonder what's happened to that, and is that still on the horizon for vaccine development?
Yeah, there are several efforts to try and develop a nasal vaccine where you get mucosal immunity. I think that the technology is getting better. You can see the clinical trials actually do show some very promising results. But there are several issues. One is now getting very difficult to do clinical trials on COVID because so many of us now have hybrid immunity, including, mucosal immunity. And so to find people who would still be susceptible to getting COVID is now getting harder and harder, right? I mean, in terms of the numbers, you essentially, you can still do the trial, but now it's going to take a much longer time. And when the time is long, then the cost is going to be high. So that kind of put companies off and think about whether this is worth the money that they will have to spend. Two is that we're still learning a lot about mucosal immunity, and that it may not, at least in terms of the cells that reside in the mucosal lining, they don't last as long. It doesn't mean that you lose immunity, because I think the way immune system works, it turns it on when it needs it, and then it kind of scale it down when you don't need it, right? Otherwise, you'd just be wasting a lot of energy unnecessarily. So because these cells are more variable in the mucosal lining, it's harder to determine whether someone's really got that level of protection that you desire from a lab test than say measuring it in the blood. So I think there are multiple challenges still that are maybe that still need to be overcome, but the technology is improving.
Okay. So, and moving on from there, I'm just wondering whether you do anticipate any further significant breakthroughs, perhaps just on the COVID-19 mRNA vaccine updates that we're getting.
Breakthrough. I guess the only breakthrough that I can think of is the self-amplifying mRNA vaccine that's been licensed in Japan, and then more recently, a few months or a few weeks ago, in the European Union through the European Medicines Agency. So that's another technology that's kind of moved along, and I think that kind of maybe it may not have that much of an application in terms of COVID, at least in some parts of the world, but I think that it can now gone through some rigorous reviews and still pass through and say that this is safe and useful. Perhaps it's another platform or technology that we can use in the future outbreak response.
Okay, and just as a wrap up, I'd like to ask you what lessons you think that we can take away from the COVID-19 vaccine development process, and how can we really apply this to being prepared for a future pandemic or emerging infectious disease?
Yeah, so I think what was really remarkable about the COVID-19 vaccine development was that it was done in less than a year, right? From the day we got the sequence of the virus to the day we actually licensed the vaccine, it all happened in less than a year. I think there are pros and cons. One is that it tells us that it can be done. We don't need years to develop a new vaccine. It can be done within a short time. But I think at the same time, people forget that the mRNA vaccine technology had been in research for nearly 20 years before COVID came around. That there was this period where we had to build that body of knowledge so that we knew all the intricacies and how to use it. So I think that tells us two things. One is that during peacetime, we need to invest in research that then puts us in a much better position to be able to respond. Two is that, there are also a lot of concerns like, are we rushing things? Is a vaccine safe if it's done so quickly? I think the science of vaccine safety is another aspect that perhaps could be improved upon, right? That we don't have to rely on people reporting side effects to know whether the vaccine is safe. That the reason why we have side effects, the reason why we have, severe adverse events and all that is because of a lot of molecular processes that are at play. And if we can understand these processes, then perhaps we can be more confident in the way that we communicate with the public in terms of the risk, right? That if some processes cannot happen, then it will cannot suddenly out of the blue turn around and break the rules of physics of biology. So, like for instance, if the light switch is not on, the lamp will never be on, right? Because no electricity will flow through it. So if we can understand it to that level, the circuits and everything, then we will be much better in the way that we can assure the public that what we have is a very safe product.
Okay, fantastic. Thank you so much, Prof. Wee. So I can maybe conclude by just saying it's a lot learned, still a lot also to look forward to. Okay, and I'd like now to invite Professor Sebastian, and I do have some questions about the COVID-19 variants, because we know that although most COVID-19 infections are now mild, we are still continuing to track the SARS-CoV-2 genome through global surveillance. Why is this still important?
So the element that Eong mentioned, this hybrid immunity, is what makes the difference. The variants haven't changed that much, so they are not milder inherently. So it is very much an interplay between how well these variants correspond to whatever immunity we have, natural or from the vaccines. It is important to keep an eye out on bigger changes. If we go back, how during the pandemic we had more explosive changes happening. Let's say the Delta variant, when we could see suddenly within a month new variants taking over, or Omicron that also had very different characteristics. I saw there was a question in the chat to compare what is the difference of Alpha, Delta, Omicron in the similar way that I explained for Mpox with the car models. And this also will tell you a bit of why we are still looking at the changes. So the Delta variant was, from a virologist point of view, more like a race car. It was giving higher infection rates, and also at that time the population was less prepared. In comparison, the Omicron was more like let's say a standard compact car, versatile, able to go in most places, where humans are, and but not so fast. Fast in a way in terms of causing like very high titers of infection. However, because it could go in so many places, it's still very relevant. If we look at the amount of changes that you can see now within Omicron, these are now not different cars again. These are more license plate changes. So the pandemic also brought up scientists, virus hunters using tweets to say there is a new variant, there is a new variant. And you could see that throughout these many years, there have been only a handful of significant changes. So much less than tweets have been discussing this. And in terms of these new variants, it's still important to look at them. It's to understand the trends. It's a new virus that continues to be circulating, just like we've been studying influenza over the years. It does make sense once in a while to update the composition of the vaccines, not just the technology of the vaccine. And you also have to think of it that way. If you compare it to the fires in Los Angeles, for example, imagine you don't have any surveillance there. You don't know when a fire starts. How do you know when to evacuate the people? Sometimes things can happen very fast. And I fully agree that there needs to be a very reasonable, measured approach to how much surveillance is needed at different times. It's much more important that we have a broad distribution, that low and middle income countries contribute. In fact, in the GISAID data platform, we've seen in the peak times, there were about 1 million genomes in a month. Now we see about 10,000 per month. What is important is that the number of countries that share these sequences hasn't diminished in that same amount. It was often an over-sequencing during certain parts during the pandemic, and now it's much more measured. So we are able to distinguish different variants in different continents, and the sharing continues mostly through the labs that also do other types of surveillance, influenza surveillance, RSV surveillance.
Thank you. I really like the analogies that you give. I think even for me, that makes it much easier to remember how we think about the variants. I just had a question because we are also talking about, monitoring what the clinical profile of the pathogen is, what the severity of the infections, how many severe cases there are, what is the mortality rate of the different variants. And I'm just wondering in this, if you're just talking about studying the genomic diversity, what is the specific mutation perhaps or patterns across the variants that have had the most significant impact in terms of what we know of clinical outcomes, in terms of diagnostic accuracy and vaccine design strategies?
Yeah, so it is important to understand a bit more about where the different mutations occur. And because there have been now a lot of studies, we understand from the 3D structure of the virus. So the sites that are important for infection of the human host cell, the sites that are important for antibody binding or T cell recognition. So whenever we see changes accumulating in positions that we know have a stronger phenotypic role, then we'll watch more closely. The analogy there is that it does not necessarily be a license plate mutation, but it's the engine size mutation. So it's like from 1.6 to 1.8 to 2.0. And these are some of these individual mutations that we are always looking out for. Similar for drug resistance mutations that has been established very well for influenza too.
Thanks. I need to ask you more questions to get more interesting analogies. But perhaps I'll ask, in your study of SARS-CoV-2 genome so far, what has been the most surprising aspect about the evolution of this virus?
I think for me, the appearance of Omicron was one of these big surprises. Because usually these different variants, they are, let's say, 5 to 10 mutations apart. And this can be explained by, some gaps in surveillance that you can't see every step of the evolution. However, when Omicron came in, it was 45 mutations away, just in the one critical part of the virus. And that was a big jump. And of course, we were wondering, was this happening in another intermediate host? Did this happen in a single immunocompromised individual? And if so, this reminds us, how many surprises the virus can still have there. And that reminds us also why it makes sense to, in different parts of the world, continue to have a measured surveillance program.
And now I also wanted to jump on, the surveillance programs that I think were really established and really took off during the COVID-19 pandemic. And obviously, this has been, as we saw, very useful and very, very beneficial. But can I ask now, is there also an element that, now that the COVID-19 pandemic is considered over, has this somewhat diminished, or how has that affected data sharing?
So clearly in the overall volume, as I mentioned before, it went down from up to 1 million sequences, genomes per month, to about 10,000 per month. There have been studies by colleagues from find how much surveillance is needed in order to be able to detect new variants emerging, variants that are also relevant. And in terms of among the 18 million genomes we have accumulated worldwide, they're in this GISAID database. 215 countries and territories have contributed them. So in the peak times, we would have 150 countries submitting the data regularly. Now we are, let's say, before Christmas, when there were cases, was 90, and now we may be at 70 countries per month. So there is still a considerable effort, but this is also possible because the technology has advanced. It is not that expensive to create a few genomes. It's only very important to have this well coordinated. And I think it's a global responsibility that everyone plays together and also helps low and middle income countries contributing. And of course, they are worried about, is their data safe? Is it equitable in terms of how the data sharing happens? And I think the pandemic has shown that the whole world can contribute. There is no exploitation of the low and middle income countries, and rather instead we are all happy to work together. And this data sharing has been continuing and is continuing.
Wonderful. Thank you so much, Prof. Sebastian, for sharing that. And I'd also just like to thank Prof. Wee again, and both our guests for coming on our webinar. And I hope that the audience can see why we still talk about COVID-19, because what surprised me is that there's still actually so much to learn and so much that we can discuss. So now I'll throw back to David, actually. I want to ask you the same question. What has surprised you the most about our discussion so far, or what are your takeaways?
Well, I'm interested in a sort of a macroscopic view, and that's the science is great, and I've learned a lot, reinforced some notions and maybe adjusted some notions. But I think the interesting thing is we spoke so strongly about the need for international cooperation during COVID, and really chided some of countries that maybe didn't play fair. And we swore that in order to do better, we would need to cooperate and address issues of inequity. But I wonder, Mpox is the next opportunity for us to prove we've learned to play fair. And I wonder what Eong and Sebastian think about that. I know Sebastian addressed that as far as some of the data sharing issues, but I wonder what their thoughts are with regard to things have changed. And even in the last few days, things have changed further with one of the larger donors has pulled out of some of these. Is that going to affect CIDER? Is that going to affect any of work? Yeah, what are your thoughts? Don't be bashful.
So you asked explicitly for the funding. So the nice thing about the GISID initiative is we are globally positioned with many different funding sources. So it would be dangerous to be dependent on single individual funders. In fact, I think the WHO Global Influenza Program is a critical component of global surveillance. This is something that is very important to continue to support. Some of the data that we receive comes also through this program. I think in general, we should think of it is our responsibility to be able to respond to new outbreaks. That means the focus is not in continuing just COVID surveillance for the sake of COVID and understanding COVID better, but maintaining capacity in these different parts of the world. So because there has always been a new virus popping up, a new variant. So I think being ready, pandemic prepared, that's a responsibility the whole world needs to shoulder. And I think the world is bigger than just one country.
Very diplomatic. And Eong?
Yeah, I think David, you started by saying that infectious disease or pathogens do not recognize borders, and I think that's in essence that's what we're dealing with, right? And for although public health and all that, but because of the nature of it's part of the government responsibility, then there are laws that govern what can be done within each land. But in reality, we need to think beyond our shore. So in some ways, it is somewhat disappointing. I mean, it's not somewhat. It is very disappointing that such a leader in science and in public health in the past has now decided that they're not going to be part of the global community in terms of improving health. But hopefully, over time, sense will prevail. And that's my hope.
Hope springs eternal. Thank you so much. And we apologize for keeping you past the appointed hour, and so we thank you for joining us tonight, and let you go and enjoy your dinner. And Dale and Louisa and I are going to discuss a couple of items.
Thanks.
Let's see, we have some questions from our audience that came from those who registered. And Dale, you want to address the question of how to gather disease data more effectively? Have we learned from COVID-19 and Mpox?
That's not a question. That's a question from you, right?
I'm sorry. No, that's a question from one of our participants, verbatim, and for those who registered.
Okay. Listen, I think we're very good at surveillance. We've got clinical surveillance. We've got event-based surveillance. It's obviously stronger in some countries than others. Certainly Singapore, it's very strong. The question I'm looking at suggests now that COVID's endemic, should countries sustain their surveillance? I think it runs at two levels. We don't have to be doing the mass testing and proving that everything's COVID anymore. And whether it's influenza A or B or metapneumovirus, I mean, we still track it with sentinel sites. But I think in parallel, Sebastian's efforts need to continue. And as he says, they're downscaled, but we don't want to be blind. That's what surveillance is, right? It's eyes. So what I hope everyone can see is that outbreak responses have to be fluid, and obviously now we're setting back into a more sustainable endemic mode, but at the time we needed to watch it very closely because of the risk of overwhelming health systems.
Great, thanks, Louisa. I have a question for you. How does we've talked about a CIDER, but how does CIDER's work dovetail with your work with GOARN and other initiatives under World Health Organization?
Yeah, thanks. I mean, I think that the simple answer is that we're all really working towards the same goal and the same mission. So NUS is a GOARN partner, and being not only on the steering committee, I'm also the focal point. So it's really about this collective network of partners sharing knowledge, being aware and alert, and looking out for different areas of concerns, working together to really build resilience, not only global deployments, but also now building local resilience within countries. And I think that's a very central mission for CIDER eventually, is that we really want to strengthen countries' capacities to respond to outbreaks.
Great. Dale, did you want to comment on some of the discussion during the webinar this evening?
No, not really. I think it was really good of those two guys to come on and share what's happening, especially behind the scenes and why. So, no, I'm not going to echo their comments.
Louisa, anything?
I mean,
if
I'm
not,
going to echo Prof. Dale. Actually.
Okay, if not, Dale, I'll turn it over to you to maybe discuss what's going on, recent announcements from CIDER.
Yeah, thanks. Thanks for this blatant opportunity to self-promote. So for that, I'll just take 2 minutes. For those who don't know, we've recently established a Centre for Infectious Disease Emergency Response. And if you want to have a look around our website, just Google NUS and CIDER, and this will come up, and it's the easiest way to have a look around. But our two biggest showpieces are this textbook, which is based on over 100 authors from around the world that I've known, or they're either my colleagues or they're colleagues of colleagues. And that's put together 39 chapters, and it's very exciting that 2 days ago they arrived. So we're actually got hard copy, but it's also available free online. So again, if you go to that QR code or go onto the CIDER website, you can have a look at it online. You can decide whether you want to buy a copy or just use it as an online reference. So I'm really not fussed. I don't get the money. So that's this textbook, and it's really the first time we've had everything about preparedness and response in one place. So very pleased with that and very pleased by the support we got. And moving on from that, we're morphing that into as the textbook for a Master of Science in Infectious Disease Emergencies. So if anyone's interested in becoming the next authorities or just developing their own information body, there's the courses offered are all listed there, and they're all on the website. It's going to be all adult learning styles. We're going to have multidisciplinary participants and multidisciplinary faculty, and they'll be from all over the world. So, with real life expertise. We've got an innovative schedule, which means that people from overseas don't have to live in Singapore for the whole year. They can come and go a little bit because of the way we've timetabled it. But at the end of this, you'll have, maybe 70 or 80 people that you've done the course with, and you'll be developing your own networks for future years. So I think there's a lot of good stuff happening here, David, and we've got a lot of good supporters, and hopefully we'll get a few more after today.
Yeah, congratulations, Dale and Louisa. This is both projects are major undertakings, and you're really filling a gap that existed. So kudos to you for the time and effort. I know it's been quite consuming. So let me close this evening.
I should have just mentioned applications are open until April, and the course starts in July.
Okay, thanks. Okay, we're gonna we thank our experts this evening, Professor Eong and Sebastian Maurer-Stroh. Our subsequent episodes will be every 2 to 3 months. Please look for our notification in your when the next episode's date and topics, and remember to submit your questions when prompted and suggestions for uplifting relevant songs to close the next episode with attribution. That's all from us tonight, bidding you a good night and a better tomorrow.
Never know how much I love you, never know how much I care. When you put your arms around me, I get a fever that's so hard to bear. You give me fever when you kiss me, fever when you hold me tight, fever in the morning, fever all through the night. Oye, buddy, nada más quiero decirte que no se debe hacer eso. It's not nice. ¿Entiendes? Mírame a mí cuando te hable. Este es mi número, y si tú me fastidias más, te voy a dar una garnata que te va a dejar bobo. So cool it. Sun lights up the morning, moon lights up the night. I light up when you call my name, 'cause you know I'm gonna treat you right. You give me fever when you kiss me.